Good morning, everyone. My name is Jun Han, and today I'll be demoing my face recognition attendance system PSM2. First of all, let us take a look at the introduction. Attendance is the important evidence that shows students' effort and discipline in their study life. There are many research also shows that attendance is an important factor and directly influences a student's academic performance. According to UDM guidelines, if the students have less than 80% of their attendance without any valid reason, then it will be given a warning letter and also not allowed to sit for their final year examination. And students tend to use the limitation of QR code attendance system to commit frauds. Inside the problem background, from the lecturer's standpoint, fraud approaches keep on increasing among students. So how they do it is to capture attendance QR codes and share among themselves, or edit the link of the previous QR code and generate a new one to scan it and take for attendance. They do this because they cannot bear for the consequences of unreasonable absence. And also, lecturer may want to recount the actual attendance manually if the students' numbers does not meet the attendance list, and this is time consuming. It also interferes when teachers are counting the students and during the ongoing teaching process. And from the student viewpoint, students may have poor internet access when scanning the QR code, making them unable to take the attendance. It also relies on devices like tags, mobile phones, and may run out of battery or camera issues. Filling up attendance slips is also one of the problems during exams, and it takes up precious time if the exams start on time. So the proposed solution here is that I will develop a face recognition system that is more secure and also combat fraudulent approaches, as students need to be present physically to recognize their face. Students can scan the attendance using facial biometrics without relying on any devices, tags, or applications. So the face recognition features inside this, including face detection, face recognition. The liveness detection is implemented to ensure the authenticity of the student face. So what is liveness detection? Liveness detection is an anti-spoofing security feature that detects the face in front of the camera and differentiates between a real and a photo or fake face. Several approaches on the market is that eye blinking detection, face texture detection, and CNN detection, also known as convolutional neural network detection. So CNN approach is used here, and it is chosen because it can detect different cases like refractions on face and also handheld device when showing the camera. The only downside of this is it needs more computing power and slows down the whole scanning process. Next up, we'll take a look at the face recognition models. So CNN is used in all these cases: face detection, liveness detection, and also face recognition. So the flow of deep learning models is shown here, which face detection will detect the face, and CNN is used because it has higher accuracy, and the model is used is ResNet. The next one is, after that detecting the face, the location will be sent to liveness detection, and the frame will be analyzed again using liveness detection to detect the genuine presence of the living face. The model used is liveness net, which is a customized model that was trained from scratch. And after proving that this is a real face, we will move on to face recognition, where it recognizes face by extracting and encoding facial representations like my eyes, my nose, and compare it in database. The results are not great initially, so transfer learning or future training is done using FaceNet to improve the performance. Next up, we'll take a look at the methodology. So Agile method is used because it can emphasize on working prototype. It also implements incremental and continuous iteration. The last one is because it has fast response to changes and it will not affect the development process. So in phases of Agile, there are 7 sprints here. The first sprint, I'm doing requirements gathering, and then the second one will be system design. The third one is implementing the face recognition model, and the 4th, 5th, and 6th will be development of academic admin and staff module, student management module, and also attendance module. The last one will be doing the overall testing of the system. Inside the technology implemented here, the front end, I'm using HTML, CSS, and also JavaScript. And the back end, I'm using the technology Django. And the face recognition backend technology, I'm using the models that we have said just now, the FaceNet, ResNet, and also LivenessNet. The database I'm using is MongoDB, non-relational database. Inside the requirement elicitation, this project does not have any stakeholders, so the requirements will be elicited from system inside the research journals. So there are 4 journals I'm taking here. One is the attendance system using NFC. The second one is attendance system using face recognition. The third one is RFID-based student attendance system. And the last one is fingerprint-based attendance system using microcontroller and LabVIEW. So the requirements are extracted, analyzed, and also compared. Inside the use case, I have 15 use cases here, and there are 3 actors, which are academic, admin, staff, and also student. There are 3 modules inside the use case diagram, which is academic, admin, and staff module, student module, and also attendance module. Academic, admin, and staff module, there are 4 use cases and 2 users. So academic admin can register staff, manage staff, and also edit profile, and also log in. So staff cannot register themselves, so this is the work of academic admin. Next up is the student module. So most of the thing done here is academic admin, and student is the only one that will register the details of him or herself, and view students and manage students will be done under academic admin. So the functionalities inside attendance module is that staff can create attendance and also update attendance and also view attendance, and student here will be the one that is recognizing their own faces and take the attendance. And then academic admin will be doing adding subject, managing session, and he can also view the attendance. Inside non-functional requirement, there are several securities inside FRAS, which is system authorization, user roles restriction, where academic admin will be logged into the academic admin dashboard only and not the staff dashboard. The login also use reCAPTCHA to further prevent any attacks. The reliability here, the face recognition feature will still scan at 3 frames per second, even though the number of students increases over time. Portability here, we have used several types of web browsers. The availability here, so the system will be always available to academic admin and staff at most of the time. The maintainability will be managed and modified to meet the functionality of the system. Inside component model, MVC, which is model, view, and also controller, everything will be connected. And domain model, the main user here will be staff and also academic admin, and staff can do attendance setting and also attendance recording. And academic admin will handle all the subject session details and student information. The next part is system development. There are 4 components of system development inside this system, which is deep learning development, basic code development, user interface development, and also database development. The first one will be deep learning development. So this is the CNN layers for liveness detection, the convolutional layer. And this part is the training pipeline of liveness detection model, where it will initialize the model, early stopping. This one is set the hyperparameters, train the model, and also evaluate it. The next one is the result of after the training. So result after evaluation. The graph is not that nice because there are not many data sets. I cannot get more data sets anymore. The next one is the code segment for overall face recognition. So over here is detection. And then this is the logging the representation of the face. And then this one is liveness detection. The last one here is the face recognition, and you'll get the embeddings and compare with the database. Inside basic code development, code segment for login function is shown. And this is the login function, reCAPTCHA, and all those login authentication things. The next one is user interface development. So this is the code segment for login page. And inside the last one, database development, MongoDB is used. And as we can see here, it is connected to PyMongo and the connection. This one is the query for taking the face representation from the database. The next one we'll be talking is user acceptance testings. And the participant I found is a secondary school teacher with deep learning background. And the session is a face-to-face session on the 3rd of June. And the first user manual was given to the participant, and she will follow the steps. The information gathered after the UAT is the time taken to complete each task, the SUS satisfaction score, and also the feedback and suggestion from her. The UAT also, after counting the SUS score, it is shown that it is 82.5%, which is excellent. So in conclusion, the objectives that has been achieved is assisting lecturers to take attendance and more securely and efficiently without worrying about the students committing fraud. The second one is successfully develop a system using the Django framework and MongoDB. The third one is successfully tested FRAS using UAT. And the future improvement that can be done is future research on improving the performance and accuracy of the face recognition model. The second one will be gather more data sets and train the model and achieve human-like standards. The third one will be scale up attendance taking in large science events or exam. The last one will be adding student account to let the students check their own attendance. So that's all from me. Thank you.